So welcome everybody to the MSR 2022 Junior PC training session. My name is Olga Basil and I'm the co-chair of the Junior PC track. Together with my co-chair Kla, we are organizing and running two training sessions. The first one is happening today. And these sessions are really organized to introduce early career researchers such as PhD students, postdocs, even practitioners who might not have prior experience in serving on the program committees in software engineering venues to better understand the best practices of reviewing software engineering papers, what to avoid, how to be a good reviewer, how not to be reviewer number two, and just really to strengthen your reviewing skills, but also to learn from the senior researchers. This session, again, will be recorded and will be available and shared on the MSR 2023 YouTube channels and channel. You will be notified of that. And it is my great pleasure to introduce our today's speaker, Professor Tim Menzies. Professor Menzies is a professor at the North Carolina State University. He is an international, well-published scholar with over 280 publications. He has served on many software engineering program committees, including our top venue, such as ICSE, FSE, ACE, and many other software engineering conferences. Moreover, Professor Menzies is the editor-in-chief of the Automated Software Engineering Journal, as well as an associate editor of the IEEE Transactions on Software Engineering. Professor Menzies has served on really multiple boards, editorial boards for many software engineering journals in the past as well. So as you can see, Professor Menzies has extensive publishing and editorial experience, and we are very happy and honored to have him talk to you today. Before I pass the mic to Tim, I'd like to mention you that we will have a live Q&A at the end of the talk, but if you feel more comfortable writing the questions in the chat, we can take them during the Q&A as well. So the screen is yours, Tim.
Great. So my slides are on the screen?
Yes, we can see them. Okay,
and I'm getting some messages saying admit person, admit person. Are you
I'll
getting
handle those? Yeah, I'll handle
those. Okay, fantastic. Thanks so much. So thank you so much, MSR, Olga and Clark, for inviting me. This is a really important topic, how we can do our reviewing better. I'm from NC State University. We're proud to say that we're a natural choice for doing engineering on the East Coast of America. And if you're doing software engineering, we really are a good choice for doing research. We have Greg Ruthermroll and Laurie Williams, myself, Marcello, Sarah Heckman, Katie Stolle, Sandeep Katal, Jason King, and John Paul Ore. So if you want to join this wonderful group of people, we are actually advertising for positions right now, but we are moving to interviews right now. So you really need to get your materials to us basically this week. Do not delay if this interests you. And let's see if we can get that little laser pointer. Great. All right, so Olga mentioned Reviewer 2. There is actually a Facebook page, Reviewer 2 must be stopped. And here we see the dude saying, well, that's like your opinion. And that's what the reviewing process is. It's opinion, informed, intelligent, and opinion. And it's the opinion that selects certain science and means that certain things get published and certain things don't. There are actually statistical studies. I took the title of this paper, of this talk, from a paper called Dear Reviewer 2, Go F Yourself, where David Peterson shows statistically that Reviewer 2 is not the actual problem in software engineering. Reviewer 2 is not the one that always dumps on you all the time. Statistically, it's actually Reviewer 3. It's a fascinating analysis, tongue-in-cheek, but it was published. So if you want to read about, if you want to know where the title of this talk came from, it's there. More seriously, I want to say that this community, MSR, needs to be really proud of its reviewing standards. Ahmed Hussein and myself watched in wonder and amusement when at ICSE 2018, some people from the reinforcement learning community came and said the empirical standards they're trying to impose. And they said, look, wouldn't it be great if we had papers that had experiments and tried different things and explored hyperparameters, and the code is linked and methods for choosing the hyperparameters are actually stated. And then there's actually things like, wouldn't it be great if we had like significance tests? And you can see less and less and less and less and less down here. The thing is, Ahmed and me were sort of kind of giggling because all of these are completely standard in a software engineering paper, and particularly in an MSR paper. So before I do anything else, let's just make sure that we're proud to say that the empirical standards in the MSR community are much greater than many other communities. So let's be proud of what we're doing, and let's make sure we preserve that tradition into the future. That's your job. Okay. Beware. So now we're going to have a whole bunch of joke slides. Beware the AI predator. They come from another space to steal our data. So if there's something that me and 100 other people have done for decades, like GitHub issue close time, predicting that, and someone comes through and proposes 2-3 neural net papers, neural net methods for doing that, and doesn't compare to decades of work previously published in MSR, I call bullshit. I say, come on, guys. It's all very well to work in one little area, but you got to talk about the biggest space. So we do have, as a community, have an interesting task right now to define ourselves separate to AI. And I have much to say on that, happily, unfortunately not in this talk, but there's much that we can say. Well, we can separate what we do in SE from what's done normally in software engineering. But beware the AI predator. Here is a review posted. Andre Zeller put it up on Twitter. It is the most vacuous, uninformative, generic piece of bullshit I've ever written. This review could be written about 1,000 papers. It's almost like the reviewer never had to read the paper, just put it in a macro and spat it out at one go. So of course you need to explain better the context and make clear what's novel. And maybe it's useful to define what you're doing before you do it. And maybe it's better to explain the design decisions and what's new here. And maybe there's some algorithm that you have to compare with you didn't do here. And maybe you should use more data sets. And maybe you should talk about sensitivity, scalability, et cetera, et cetera. But every damn paper has got this. Every damn paper. If this is the reviews you're getting, no one's actually lent in. No one's actually walked in your shoes and tried to say what is unique about this paper. No paper is perfect. The more any paper can be picked apart, the question is it saying something interesting and timely? So please do not make your review my example for this talk next year. Okay, say something specific about the paper. Okay, now here are some traps for young players. I firmly believe papers are rarely accepted. They're rather not rejected. I firmly believe that what really happens is when we review papers, very rarely do we say, this is amazing, this is incredible. Really what happens is you start reading and go, hey, that's funny. Hey, that's funny. Hey, that's funny. Hey, that's funny. The papers that get accepted are the ones that are smooth as silk all the way across. You put your eye on the front, you read through to the back, and there's no bumps, nothing is cutting your hand, nothing's hurting your eyes. For that to happen, the authors have to present things in a really nice order. They have to be answering the questions before the reviewer asks the questions. They've got to put their definitions before the rest of the paper. They've got to have really clear graphics. They have to have research questions that talk to some point. They have to have results that talk to those research questions. These are all things which, if you don't see, you start saying, this paper's weird, this paper's weird, this paper's weird. And this is the henpecking party that reviewers can get into, where one reviewer sees a problem and says, hey, this is a problem. Another reviewer pecks that problem and finds more problems, and then more reviewers peck, and finally you peck the paper to death because any paper has got problems in it. You want to write a paper that never starts the pecking party. It wants to be the chicken over here that no one ever actually hits. So I know that if I start getting involved in a very lengthy debate with other reviewers, and I mean lengthy, like lots and lots of comments, I know we've left behind semantics and meaning, and now it's a random factor whether the paper gets accepted or not. And it's the author's fault for not writing a smooth paper, for writing a paper that jars and alerts and bothers reviewers. We need to talk a little bit about the sociology of reviewing. As junior reviewers, you're here to service science and service your career. And just to talk about that second point, servicing your career, your reviews now have two audiences. If you look what's happening inside, say, Hot Crap, there is a button where other people can lean across and say, good review, which means that you've now got a couple of audiences for what you're doing. One is the author of the paper who's going to review it. And secondly, there will be the program committee chair of the next conference that leans across and says, how many good reviews did that Menzies get? So you have to write good reviews that stand up to the standard of the rest of the paper or the reviewers in the conference. But be warned, newbies get worried at this point and start writing War and Peace, these really voluminous reviewers. So I tried to find the shortest review of any of my papers that I thought was reasonable. And I tried to find what were the structures of that review that made it reasonable. And it's far, far less than what ICSE does, by the way, just a heads up. So how do you tell newbie reviewers? By the length of their reviews. The more nervous you are, the longer you write. The more confident and assured of where you are, the less you write. So here is a paper of a review of one of my papers. There's a summary at the top, and this is really important because when editors like me have to review a paper and say what it's about, the summary is really important. There's a list of things that are really good. There's a list of things that are bad, the cons, there are problems. And there's a few nice things in this list. Right now, can you see that there is this phrase, there is much literature saying blah, blah. And if the reviewers don't put in a reference to that much literature, I call bullshit. I've suffered in my career too often on reviews of the lines of, look, this has been done before. There's so many publications on this area, and the reviewers don't actually list those publications. So for the love of goodness, P, if you're going to say there's much literature discussing, put in the reference to the rest of it. I mean, it really is 7 seconds to go to Google Scholar and type in the terms you're talking about. Or go to the paper you think that this paper should have reviewed and gone, you know, who cites this paper? It's really 7 seconds to find a whole set of papers that might be relevant to this paper. So if you're going to complain about a paper that doesn't talk about the current state of the art, put in what you mean. Otherwise, I call bullshit. Another thing I like, you see how this particular reviewer has separated out their cons from other issues. What this reviewer is saying is, these are things that really bother me, and unless you fix them, I'm not going to accept this paper. And they're separated out from lesser issues. Now, when we get round to sort of writing reviews that have a rebuttal, where you write a review and the authors get a chance to reply to it, it's really, 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 really useful, and this is not done in our current templates, to separate out the issues that you think are absolutely critical to getting a paper accepted, and the issues that are, well, you know, you could have done this, but then maybe you could have done that as well. So I really wish people would separate out their critical issues from their non-critical issues. Just a few resources. There's the ICSE 23 guidelines here. This is their reviewing. There's a large repo of different empirical standards up here in what's called the SIGSOF notes. I will say that this is much more authoritative than that. This is stuff that's actually been approved and in use. So the ICSE papers we're talking to now are actually being reviewed by these standards. And these have got different things to MSR. Okay, so MSR is much more focused on the empirical and the algorithm. And there's more things in here than what for MSR, but it's worth reading. The SIGSOF notes. Well, even though these are called the ACM Special Interest Group metrics, I noticed that they've never actually been endorsed by SIGSOF. They're more like preliminary notes of what some people, like me, were trying to make a standard. And we might get there one day, but you know, there hasn't really been much activity on these after about a year's work. But if you want to know about optimization studies and data science and repo mining, there's things here to consider, but don't treat them as gospel. They're ideas you might want to consider. So these are definitely maybes. These are absolutely you must do for ICSE. So that's really interesting resources to explore. I do want to hone in on some of the ICSE 23 review criteria, which I disagree with. So if you go to ICSE, we're meant to review things by soundness, significance, novelty, verifiability, and presentation. And I've spoken to you above about the need for presentation, that papers are not rejected, they're not accepted. And here you got the presentation problems of people not having a linear argument in their paper and not making it clear what they're doing at the start and not delivering to that at the end. But I do want to talk about 2 points that ICSE stresses about significance and verifiability. Now, regarding significance, I find it incredibly unlikely that most reviewers who spend 1, 2, 3 hours on a paper understand a field as much as the authors who have spent 1, 2, 3, 4 years of their life working at it. So significance, you know, I don't see the point of this paper. I don't see where this is coming from. This paper has little practical application. Well, firstly, the paper could be reporting from an area of industry you're not familiar with. The paper could be talking to concerns you're not familiar with. And so, yes, there are some people with enough experience that when they say this is insignificant or this has been applied to a very simple data set, it's really boring, I'll believe them. But there's a lot of reviewers who talk about significance, and I cry bullshit on that. I cry that I would submit that generally we don't know how to do significance. So I would be not so stressed on that one. And regarding verifiability, which is a statement in ICSE, have you considered what kind of papers we're losing because of an obsession with verifiability? Here are 2 papers very famous in the field. And by famous, I mean famous. I mean, you know, careers were made out of these 2 papers. And one of them has got, you know, it was 1972, and it's got over 7,000 citations. And here's a paper from 1987 with nearly 11,000 citations. And this one is David Parness's on the criteria to be used in decomposing systems into modules. And you just cannot say the impact of this paper. I mean, this paper is what it had this massive impact in people's thinking and in practice in military software development. This paper is incredibly influential, and it has no verifiable statements. It's a sweet little case study describing how to do something. There's no what we would call an MSR, science and repeatability. Another paper is, this is the paper that gave us the state charts that ended up being in UML. This is David Harrell's state chart, a visual. There's no verifiable argument in this. This paper is saying, here is a visual notation that might be a good idea. And this is another really influential paper. And I say both these papers should have been published. I say both these ideas papers should be publishable in the modern world. And these papers will be very hard to publish in the modern world. With our current focus on we have to prove things to 7 decimal places on 10,000 data sets, these papers wouldn't even fly. We wouldn't have them. So, you know, I just want to make sure that we have to apply standards, we have to negotiate those standards, but also let's be aware that sometimes we want to throw all those standards out the window, stand on a high hill and say, this paper should be published because it's cool. So and I've started out this talk saying, isn't it great we have our standards in MSR? You heard me say that. But I also want to say that sometimes we want to let people write cool papers. Okay. Now, another thing I want to talk to is the artifact stuff. For about 10 years, we've had lots and lots of artifacts being attached to papers. And it's about time we have to call bullshit on the current artifact work. If you look at the Winter et al.'s paper at FSC last week, a retrospective of 10 years of people putting their code on papers. And what's not happening is the papers with associated code are getting more citations. And what's not happening is the paper with code associated with them is being used more. So, you know, meanwhile, a lot of effort is going into these artifact review committees, increasingly, and a lot of people are elaborating the need for different kinds of artifacts. Should we have containers, and should we do serverless, and much on artifacts? And I've run numerous artifact evaluation sessions at ICSE and ASE, and I'm saying we have to relax a lot on what we call our artifacts. I really like the software carpentries people. This is a really nice argument here describing good enough practices for software engineering for sharing artifacts. Also, just to throw to some of my own work, coming out early next year at CACM. There's a paper with Teresa Baldessera, Neil Ernst, Ben Herman, and myself, and Rahul Yedida. Ben is one of the authors of the paper on the last page. We're talking about another way of doing evaluation. Like I know right now, we're talking about reviewing in a traditional manner, the way the MSR does. I just want to say that that way we're reviewing is not written in stone. There's no effect coming out of the Big Bang saying we have to review things the way MSR does, the way ICSE does. And I want to talk about, and this paper talks about an idea called reuse graphs, which is another way of doing the whole darn thing. And that's a whole paper to talk to, and I won't have time for that. But if you want to get a preprint on that one, there's a very long URL there. Sorry about that. Okay, so here are some things I want to see in a pattern, and this will be followed by a section on anti-patterns, things I do not want to see in a pattern. In terms of my list of positive patterns, just to say the absolute beginning, obvious, it's really useful to separate the train set from the test set. So do not. I'm really worried if people report their models on data used to train those models. And there's a couple of ways of doing that. You can do a 5x5 cross-val, and that's wrong. 10 times take 80% of the data. Why 5x5 cross-val? So why not 10 by 10? Well, firstly, it's really good to randomize the order of the data, because sometimes data sets have order effects where you pull the JavaScript code before you pull all the C code before you pull something else, and so the order in the data set could be some artifact of how you collect it. So it's really good to randomize the order, and then it's really good to divide the data up into, say, 5 bins, where those bins have the same class distribution as the original. And if you did a 5x5, that gives you 25 different experiments. Now why 5x5? Why not 10 by 10 or 10 by 1? Well, 5x5 crosses the 20 threshold. You get more than 20 examples. 10 by 10 means you have to do things 100 times. And no one's ever shown me that there's, there are papers that talk about how repeating things 100 times is really good. But, as CPU gets more and more expensive and we're doing more and more elaborate things, I really like the idea of reducing our evaluation effort. So I'm about 5x5. Another thing that's much faster is train on data on the past and test on the data in the front. This is a much faster rig than a 5x5. Software comes and releases, train on the past, test on the future. I've been doing that for ages now. There is a paper here that would be a whole talk to where there is actually a bug in this scheme. And if you want to look at that, that's an interesting paper. But in both these schemes, we're separating the data we're using to train things from the data we're using to test things. And then I want to see variability across the repeats, because it turns out software engineering is a domain where there's a large variance in the performance of the models. So if you tell me that your median accuracy is 80, and some other treatment, the median accuracy is 82, and therefore the other treatment's better than yours, I call bullshit, because I'm pretty certain there's a large variance in that 80. And that when you can start considering those variances, that 82 is really not significantly different to that 80. And so one thing, if you're doing a lot of pre-processing to data, like a lot of pre-processing data, you might be addressing class imbalance, or you might be doing feature selection. It's probably, I'd like to say you must, but there are some strange counterexamples where you can't. But it's really good, whatever pre-processing you're doing to the training data, do not apply that to the testing data. If there's some intelligence that says these columns matters and those don't, if there's some method for changing the class balance, you probably want to, I'm pretty sure you always do want to do this. You want to do this on the training data and never on the test data. So you want to test on data closest to the domain data. And if I don't see that, I get bothered. I want to see, often I think it's really useful to cluster data before you look at it, because software engineering has a lot of variance. And so if you do some clustering, you end up with, not one project, but different parts of one project with similar properties. And there's a lot of reasons for clustering. Firstly, like I've got an MSR paper a few years back, 500 times faster than deep learning. And all we did was use k-means to cluster the data and then we learnt per cluster. So 500 times faster than machine learning is doing clustering. There's also a statistical method we're going to talk about in a few things called Scott-Knott, which clusters on the dependent variables, on the results that come out of this thing. And I think that's a really powerful thing. And over here is a little description of one of my favorite algorithms, where you find the two most remote points and divide the data based on that remote point. You keep dividing, dividing, dividing. And if you're optimizing, you're looking for these green things, you only have to evaluate 2 points at each thing, throw away half the data and recurs on the rest. So down here, you can find these best green things in log n time, not n time. So I really think we should be always clustering data before we go peek at it. I really think we need significance and effect size tests. And later on, I'll talk about the difference between a significance test and an effect size test. And just to say something that a million people have said before, the names we use for stats is weird. We really shouldn't say significance test. We really should say distinguishable. Can you distinguish two distributions? Much better than significance. It's really good to report results from multiple data sets. It's really good to have multiple evaluation criteria. One interesting point that comes up with multiple evaluation criteria is that if your treatments win on one criteria but lose on another, how do you decide between them? And lots of people have talked about aggregation functions. Lots of people have done hypervolumes and spreads and generational distances and inverse generation and blah blah blah. And I prefer not to do that. Here I've got a thing called Scott-Knott that I'll talk about in a minute. And each column of data is a different criteria. And these are all the criteria that I'm seeing in papers right now, like recall, false alarm. This is the number of false alarms before you find something, IFA. This is how close you are to recall equals 100 and false alarm equals 0. And this is area under the curve. And here are some other measures. And as time goes on, people propose other measures and other measures and other measures and other measures. And so you're left with this problem of how you evaluate papers based on multiple measures. And really, I mean, after having done this for years, I really recommend the simplest thing is just take something, find some primary thing like recall and sort all the rows by recall, and then mark in gray all the things that are statistically best. And so using the Scott-Knott method, here the best cells are in gray and over here. Now over here are some treatments that score 4 out of 8 on the best, and down here are treatments that have no best, and here is 1. So you can absolutely say these things are rubbish and should be thrown away. And really you want to make a case that this is the best. And this particular paper argued that this thing here, which I won't tell you about, is best. This is one that does about 1/100th of the effort of the other things. So what we argued here is that this thing was as good as anything else. But I really like seeing raw, not synthesized data. Like you could do some aggregation function that weights across all this, but you'd never see the raw data. And what we notice here is that this D2H is very uninformative on how to pick for things. Like you'd almost say that D2H is uninformative because nearly everything is getting top ranked. And then you might want to say that something like the Bree score or recall is most important for finding things because it's never in the lower ranks, but always in the top ranks. So, I want to know that sort of thing, that certain measures are bullshit, like D2H. And so give me the raw data. Don't give me F1, give me recall and precision so I can see what's going on. Now, another measure we should be all talking about are the bias measures. If you've got data with protected attributes, gender, race, age, veteran status, some social group that might be disrupted by our results, it's really, 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 really good to measure the fairness. Now, this vertical axis here is the false positive rate between men and women. So up here, it's about equal. And down here, women have 5 times higher false positive rate than men down here. And this is an application that says, should we not open a bank account for you? Should we not open a bank account for you because you're a bad financial risk? And this is one, should we not give you a donor organ because, you're going to die anyway? And this is one that said, look, should we not give you bail but send you to prison because you're going to commit crimes? And down here is the point where women can't get access to financial services 5 times more than men, where women can't get organs to live on 5 times more than men, and women go to jail 5 times more than men. And each one of these dots is a different hyperparameter. Now, for any other audience, I now go off and explain hyperparameters. For you lot, I say, there are magic tuning parameters in our learners. And these are hyperparameters, like in kth nearest neighbor, how many K do you use? And for your neural nets, what architectures to use? And so these are just 10,000 random hyperparameters picked for 4 learners. Now, the point of this example is if you only optimize for accuracy, which is the x-axis, you end up with this point A here, this point here, this point maybe here. And this is the point where women aren't getting access to financial resources. They're dying because they're not getting their organs, and they're getting sent to prison more. And there's a compromise point up here, which is not much less on accuracy. And if you're a woman looking at this data, you'd really prefer we're up here. And so while I really think we should be doing a couple of things based on these diagrams, we should be measuring the bias of our systems. We should not just be doing recall and precision and energy consumption, but we have other criteria talking to the social aspects of our work. And if we start optimizing on multiple things, we really should stop be doing regression and classification and doing multi-goal reasoning, because what we're doing is more nuanced than just making one decision. We're contributing to how these things are deployed and used in society. And the other thing is here, we really need to hyperparameter optimization. It really strikes me as weird that we have all these papers that we accept without hyperparameter optimization. Just use off-the-shelf tuning. I'm pretty sure that most of the papers that don't do hyperparameter optimization, their conclusions can be reversed in a single afternoon by a grad student just by doing some hyperparameter optimization. So that's just, but I've been making this case now for 6 years. And it hasn't been widely accepted. So, you just got to accept the community doesn't believe it. But maybe there's a few out there that are interested in social aspects, and maybe I can talk you into believing that there's more things than precision and recall. Here are some anti-patterns. Here is some tables of data that I see in a paper I call bullshit. So they're saying, look, I've got this method, treatment 1, and without it, the baseline is on these data sets, I get 43, 56, and 61. And with this treatment, I get 44, 57, and 62. And here I call bullshit, because the difference between the differences is so small, that's almost due to random noise. Now, if there were, 10 data sets, and in all the cases, there was always an improvement, and the improvement wasn't 1% or 1%. It was like 4. I might be more interested, but right now I'm complaining that this paper, my first pass is I'm thinking this paper shouldn't get published because they haven't demonstrated much of an improvement over a baseline. Like if you think about all these papers that report a 1-2% difference, by now we should have accuracies, precisions, and recalls of 4,000%. If you added up all the papers and all our history that have promised a 1, 2, 5, 6% improvement, we should now have 5,000% accuracies. Another thing that really bothers me is, and this happens a lot, people just say, my system's 6 times better than that system, because I looked at the improvement when system 1 was employed, I looked at the system when the improvement when system 2 was employed, and the improvement in the second case is 4 times bigger. Therefore, it's a good thing. But what they don't report is the baseline. So a figure, and I see this a lot, papers that report the percent improvement, but not the baseline numbers. So if you have a baseline recall treatment 1, and you have 43, 56, 61, and then you have another treatment B that gives you recalls of 44, 57, 62, and another treatment C that gives you recalls of 46, 58, 64. And what you might say is that the delta between treatment 2 and treatment 1 is 1, 1, 1. Like we're going to minus these 2 numbers, B minus A. And we have another thing called treatment 3, and its delta is C minus A, column C minus column A, at which point we see improvements of 3, 2, and 3. And so then the paper says, look, aren't we great? Look at treatment E has much larger improvements than treatment D. We're 3 times, E is 3 times better than D. And this is the argument here. And I see this a lot. People report the relative deltas and compare those, and they don't give me the baselines. And you know, I go, no. This is so small, it's not important. Another thing, I was going to write a slide on this and I forgot. Another thing I'd say here is I'm a bit worried about their baseline, the competency of their baseline system. Like here we're seeing recalls in this, recalls of 44, 57. Now, you know, what's a good recall and what's a good false alarm is of course domain dependent, but roughly speaking, if I'm seeing false alarms greater than a third and recalls less than 2/3, I'm leaning in to ask the authors why in their domain they think such high false alarms, you know, up to a third, and such low recalls, 2/3, is useful. And there are domains where that's useful, like if you're amateurizing something over a very large space. But often I see a lot of what I'm worried about with the AI predator pattern is that people come in and they say, we're doing better with our neural nets, but they're starting with recalls of like 52% or something, which means they haven't actually studied the problem and what's been happening in the MSR community on how we've gotten, you know, recalls of 53 up to recalls of 90%. And, you know, so that's another thing that really bothers me when people propose improvements on a very weak baseline. So before you do clever things, do competent things. Before you do clever things and improve things with deep learning, at the very least, generate competency at the start. Another anti-pattern that really bothers me is that pages and pages without references. If I see a paper that's got lots of references in it, with pages with no references, I think I'm reading a product release, not a research paper. I worry when they don't review recent work. There are so many papers we're getting in MSR. You go to the back and look at how many of these come from software engineering venues. And it's, you know, if the count is less than Tim's constant of 5, then, you know, then just start crying bullshit. A literature review where there's no attempt to explain why we need a new method. Why isn't the old stuff good enough? And doesn't explain the delta between old work and new work. Experiments, when you're not comparing to anything else, when you're not comparing neural methods, deep learning methods, to non-neural, especially in domain where non-neural has been successful before, that's a false alarm for me. Improvements demonstrated over a very weak baseline. Like if you tell me that this treatment is 4 times better than that one, but the baseline's a recall of 40%, I'm going, yeah, that's bullshit, yeah. No feature selection at the front. No hyperparameter optimization. This is a paper from ICSE 2015, CLAR, in fact, where here are these methods before. The blue is before optimization. So here's C5 and all these other methods. And before optimization, quite clearly, the symbolic method's rubbish. You know, the neural methods are doing better. After optimization, the neural method, the symbolic method is doing just absolutely fantastic and destroying everything else. So there's the after optimization. So this really bothers me. But like I say, I've been making that case now for about 5 years and the community hasn't bought into it. So what the hell? And if you're going to do hyperparameter optimization, please don't do a grid search. Please don't do for loops for your options. There's so many things wrong with that. Email me and I'll tell you about that. I get bothered because I'm interested in multi-objective optimizations. I get bothered when people report one goal without the competing goal. So if you see people reporting recalls without false alarms, that's a red flag, because you can have very high recalls by making lots of mistakes by having very high false alarms. So please, 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 if you see a paper that reports something that succeeds, ask for, are they measuring failures as well? So recalls and false alarms. There's also the questionnaire at the back of the paper. You know, we asked the user community, did they find our tool useful? And this is the I love you question. If an experimenter sits down in front of you and says, look, here's my tool, do you love it? Do you like it? All anyone can say is, yeah, it's okay. Yeah, go away, stop bothering me. Really, a better way to do the I love you question is that the subjects in those experiments get results from 2 systems in a randomized order, and both the presenter offering the examples and the user don't know whether the results come from the new system being assessed or some other baseline system. So let's not have the I love you question. Let's have double-blind experiments where people are comparing things between things. Yet more anti-patterns, reporting averages and not the variations, not the interquartile range or the variances. When the target class is rare, precision's really weird. Like, how many of you have ever graphed up precision recall and false alarm? And there's this neg-pog ratio, which is how big is the target. When the target's about 50% of the data, precision, false alarm, and recall are well behaved. But as the target class gets rarer and rarer and rarer, and we have SE data sets down here, the space of high precision results are in this very narrow range here, and tiny changes. It's like going for skiing and you're going down a very steep slope. The space of high precision detectors is very small when the target class is 1/250th of the whole space. So, you know, precision and even accuracy are to be treated with care when the target class is rare. Now, I still put precision into my papers because reviewers expect it. But if I had my way, I'd throw precision out for rare target classes. There's a great quote I like from Ernst Rutherford, an atomic physicist, who said, you know, any experiment that needs stats needs an experiment. I love that quote. Like, if you really need to, you know, justify your thing at the 7th decimal place with really complicated stats, you've probably done the wrong experiment. I really get bothered when I see papers that report 0.989876. You know, dude, I mean, come on, that's 98%. You know, in fact, that's 99%. Just chill out. Beware trivial improvements like 2%. As I say, if all the trivial 2% improvements we've ever had were stacked together, we'd have accuracies of 100% right now. I get worried when I don't see stats. I get worried when I don't see effect size and significance tests. And I think we're heading towards the point where I have to decide what to show you rather than everything else. So, Olga, how much longer do we have for this session?
I think if this is your last slide, we can take questions, but if you have something else to say, then do so.
Okay, is there anything else I want to say? Anything else? I suppose the one thing I really want to say is that beware deep learning not compared to anything else. Like, yes, for many tasks, generative tasks, translation tasks, for high dimensional visual tasks, deep learning is the hands down best way. But if we look at a whole bunch of other things being explored by MSR, assigning severities to issues, defect prediction, GitHub issue close time, bad smell prediction, the green bar is the stats saying that deep learning wins over anything else. The blue is the best deep learning method we could find. The blue is the best non-deep learning method we could find, and the red is the best deep learning method we could find. And measured in terms of recall, deep learning is best over half the time. But when we go to combined measures like AUC, yes, there are situations where deep learning is much better than non-deep learning. But at the other end, there are also situations where non-deep learning is better than deep learning. So yeah, deep learning is a great technology and we should explore it and it has applications, but don't get too carried away from it. Okay, and there's other things here. So be proud of what we're doing. We've got incredible standards at MSR, keep them up. Beware the AI predator, count the number of references to SE papers at the back, and if it's low, be suspicious. Maybe it's time to call bullshit on artifacts and do another kind of artifact evaluation. Fairness matters. It's really undervalued in our review processes, but there are social factors. Deep learning, do it, but be more critical of it. And there's something I didn't get to here, but hey, ran out of time. So thank you for this opportunity to talk. Any questions or comments?
Thank you so much, Professor Menzies, for the insightful advice on what to watch for in the reviews. I think it was also very useful from the publishing point of view as well. So we are happy to take any questions, and we have a hand raised from Michael.
So my question is as follows. Let's say I'm reviewing a paper and I see some pros and some cons. How do I lean towards, I don't know, weak accept, weak reject, or
I
stuff
didn't
like
hear
that?
half of that. I see some pros and some
cons in a paper, like some is good, some is bad. how do I determine between weak accept, weak reject, maybe overall reject, maybe even accept because the cons are small?
And so the paper's got the paper's, well, if the paper is doing something interesting and it has a problem, you got to make your own judgment as to how big the problem is. Every paper has a problem. Every paper has a problem. And the more you look at them, the more problems you'll find. You have to make the judgment of whether it's acceptable. Now I've been in your situation where I've tried to tease it out a bit more and said, and in the comments to reviewers, not to the author, I say, dear reviewers, I'm interested in this. I think blah, blah is really important, but I think there's this problem here. So I'd like to ask your opinion. Do you think the problems with X outweigh the advantages of Y? And actually make that a discussion point inside the review system.
Any other questions? I think, Tim, there is a question, at least in the chat. Ji Chen wanted to ask a question.
Who? Jin Chen. Yes. Ji Chen, go for it. We're here for you. Yes, I think you're saying, well, I know what a reasonable baselines are for recall and precision. I don't know what a reasonable baseline is for MCC or IFA, etc. What I would say is that if I can see the stats tables and I can see whether the treatments are separated by, say, IFA, then I'd say it's an interesting measure. But your point is there's a lot of measures that we're using that we don't have community standards for, and so you just have to ask people, I guess. But I don't know what a good IFA measure should be, for example. Comma, it should be dozens, not dozens or less. You know, clearly not hundreds.
So Alexander has a question as well.
Okay, Alex, are you accepting submissions not from ICSE 23 but from elsewhere for the artifacts?
Well, it's the 24 edition, right? So we still need to write the call. We have not
Right.
just started.
So there's functional, available, reusable, reproducible, replicable. Now functional and reproducible are basically so close you may as well throw one of them away, because you know you can, and also something's reusable if it's reused would be my definition. You know, we generally can't assess reusable, replication, and reproduced because that takes time, longer than the one conference. So what I was doing for the longest time was allowing submissions, one-page submissions, describing reuse and replication from other venues. And then I think the ICSE 22 people stopped that. And so that basically meant we were wiping out replication and reproduced. I also think that available should be reviewable in about 17 seconds. You know, is there a long-term GitHub? Is there a long-term repo like Zenodo or something? The only one that really people should be spending a lot of time on is it reusable, and which actually means taking it out and trying to run that thing. But I beg you not to fetishize the artifact process, and when in choice of two things, go for the simpler thing.
Thank you so much.
Jadeb has a question in the chat. So if the paper only uses DL methods and compare themselves to baseline.
Jadeb, I would ask, has the thing being done in the paper been done before without neural? So if we're talking, if we're using the generative properties of deep learning, that's hard to replicate in the symbolic world. Maybe some trick with associational learning or something, but the generative task and the high dimensional visual stuff is usually we just give that to the neural world. But if it's been done before, GitHub issue close time, defect prediction, effort estimation, a whole host of things done at MSR, then I would say, damn straight, there should be a comparison to non-neural.
Thank you.
Okay, you want to look at the paper by Begstra on random search. One moment, please. Begstra random optimization. Well, firstly, the long or the short of it is different data sets need different steps in different oh, I've lost the chat box. I've lost the chat box. Okay. So Begstra is arguing here that different data sets need different increments, and a grid search that's small enough to catch all optimizations for all different data sets and all optimizers would be so slow it'd never terminate. And he reports astonishingly good results with random search. And so if you're familiar with HyperOpt, which is Begstra's thing, which you can get on Python with pip install HyperOpt, does a random search around that space. So grid search is just terrible. What
Question
sort of
from
content?
Catherine, yeah.
Okay, so I've got a slide on what I think is most important. Am I still sharing?
Yes, you see the last slide.
And now we've got this wonderful thing where there is well, firstly, some of the content is prescribed. Like if you look at the ICSE 23 guidelines, they do have subheadings you've got to put in. So you get to fulfill those headings. But, there's a slide in here where I do that, and I've lost the screen right now. I can't tell you where it is. And it's like a paragraph at the front saying what it's about, maybe a second paragraph with overall comments, then a list of pros, then a list of cons, and then a list of others. And I made the point in this talk that the cons should be divided into cons and others. And the cons should be the things that actually stop you accepting the paper. And the others should be things you might want to change, but are not necessarily things stopping a paper getting accepted. Did that answer? Okay. Often, okay. Other questions?
There is a hand raised by Tim. Tim, you can unmute yourself, yeah.
So thank you for your talk. I want to ask something about this deep learning stuff again. So if we have let's say an accuracy from a deep learning method which is comparable to a more traditional method, can we really say that they are about equal, because we can't really interpret those results from the deep learning approach because we can't understand the model, and therefore we can't say that there it's not maybe big oversight.
So you can say in this domain accuracy matters. Like if you're doing let's say you're trying to recognize pornography so it doesn't get to kids, you might want to say that accuracy matters. But what you're talking about is a different measure. You're saying I want to assess my theories by accuracy and explainability. And there are various explainability measures, including putting a human down in front of the theory, put an error into the model, and see how long it takes them to find it. There are various measures. So I agree with you that we should be assessing things by more than just mere predictive performance, but also by issues like explainability, bias, and a bunch of other things. We should be the CPU cost, the energy cost to build the theory. There's a whole bunch of other criteria we should be using in assessing our models. Did that answer the question, Tim? Great name, by the way, Tim. By the way, Tim, if you look into the history of Tim, if you go back to the history of Timotheus is about doubting. If you look at the original Greek text of Paul's writing to Timothy, he said, all these verses, comma, as written by God, comma, are true and must be followed. In the context of the time, there were all these false priests rising up and little religions, and Paul was advising Timothy that there could be scriptures, in quotes, not written by God, written by just doofuses, just idiots, and we should doubt them. Now that comma, all these texts as written by God, was removed in the 12th century because it did raise the possibility that parts of the Bible are actually fake and parts are real. Can you think of anything better to end this conversation on reviewing, where the people deciding things about what to trust? And so the name Timothy, Timotheus, is hardwired into a millennia-old tradition of deciding what to trust and what not to. So great name, Tim.
Thank you again.
If you want to know more about that, have a look at Donald Knuth's 3:16 book and the chapter on 2 Timothy 3:16.
There is a question from Armstrong.
In the chat box?
No, it's a live question, so you can unmute yourself.
Hi, Tim. Thank you very much for the run through. I just want to be more concrete on the procedure. When we are reading a paper for review, what should be guiding our decision upfront? Is it like having enough reason to accept or enough reason to reject before? Because when you are reviewing a paper or reading a paper analytically, you should have a goal set mind. So,
the ICSE guidelines are very explicit on that point. We should be reading to accept. We should be reading to accept. Like when in doubt, give them the benefit of the doubt. Science is a lot of kissing frogs to find your prince or princess. Reviewers have to provide the ecosystem that supports people kissing frogs and celebrates the people that find the prince or princess and celebrate the great stuff. So most of our papers will be incremental explorations, and we're providing the infrastructure that lets people have the job that lets them kiss a lot of frogs before they find the prince or princess. We should be reading to accept.
Okay, thank you.
Looking at the chat box, 2 participants have raised hands. Olga's in charge.
Again, Ji Chen.
Okay, so regarding the artifacts package, my words of wisdom on this can be seen in the paper, the Software Carpentries paper, reasonably good practices for sharing experimental stuff. I'm all about bash scripts. You know, I've got really simple ways. Often the core of what I do is 2-3 lines inside some bigger thing. And I find myself fascinating how much I can write like 200 lines of Lua and say, this is the core of the paper, and put that online. So the artifact stuff shouldn't be fetishized into massive container cloud compute. It should be as simple as we can do it, and read the paper, good enough practices for scientific computing. And then Armstrong.
I just asked my question.
Oh, very good. Your hand's still up.
Oh, okay.
Beyond. Okay. There's actually much more to say about Ji-Chan's question. Some data sets are proprietary and come from industrial sources, and we need to be able to support our industrial colleagues if we want our industrial colleagues to be part of our community, and we do, we have to say that the industrial people don't necessarily have to give us all their data, maybe some mock-up, maybe some fake of their data, some representative samples. Other questions or comments?
Sorry. Sorry, I didn't raise a hand. Can I ask a question now here?
Yes.
Yeah. So like sometimes we receive the reviews or sometimes a review paper, and I think one question we performing a study on a few like subject systems is not enough. So we should add a lot of data sets to draw some generalizability from this
Yes.
findings. What's your opinion?
Well, how much is enough? You know, like if you look at a lot of the AI papers, it's like mathematical analysis, 2 data sets, and here's the result, or even 1 data set, and here's the result. The question of how much evidence is enough is domain dependent. I have recent papers where we looked at 1,200 GitHub projects, and there are the Canadians have got repos with research repos with 1 million GitHub repos in them. So the question of how much is enough is completely domain dependent. What I would say is look at recent papers that have worked in this field and correspond to them. I do get worried, you know, below 5 or so papers, but then if you're talking industrial case studies, you've only got data from 1 industrial case study usually. So we don't want a hard and fast number. We want a number reasonable with respect to accepted practices in the field, if that makes sense.
Yeah, thank you, Tim.
Tim, I have a question, perhaps that, you know, junior PC members might feel sometimes intimidated by working in line with the senior researchers. So how would you, what is your advice on handling and discussing disagreements during the review process?
Senior people shouldn't be dickheads would be the executive summary there. One of the reasons that our committees are mostly junior and not so much senior is an effect that Olga's hinting at, where, well, you know, I could be a dick. I could just, you know, say, oh, well, that we did that in 2016, and this has all been done before, and the community has to have its own learning curve, its own training ground. If you feel that your voice is not heard, you do have an appeal process, which is the program committee chair, and you can, the junior researcher can ping that researcher at the top. I have heard, you know, triple blind proposals where reviewers don't know each other's name and just work that way. But I got to tell you, I'm pretty good at picking other reviewers by this stage. Like, you might think you're anonymous to me, but you might not be so anonymous to yeah, well, that might not be true. That might not be true. But you know, Olga, if you think that problem's endemic, like, I think the MSR community and the ICSE community is very aware of process improvement. So if you think that's an endemic problem, that's actually worth discussing and resolving within the ICSE and MSR community.
My recent experience doesn't say that, you know, this is still happening, but just, you know, our junior PC will have to work together with regular PC, and they will be treated in the same way, right? It's not a shadow PC. There is a difference here.
Well, I don't know who's senior. I mean, okay, I know about 20 senior people, but if you look at the size of the MSR and ICSE, you know, I'm often working with people that I've got no idea if they're junior or senior. You know, so I don't rush off and Google everybody. As soon as I talk to them, I just try to reply to them. You know.
Sounds good. Any other questions?
Before we finish, John Grundy's talking, and we'll get to Kayla's question in just a second. John Grundy's talking next in this series. You want to listen to everything he says. John Grundy, for a while, was the guy that did the desk rejects at TSE. You never even got to reviewers if John Grundy picked at your paper and said, no, mate, no, that's not going to fly, mate, no. So you want to listen to everything John Grundy says. Kahelia, if I've got that even approximately right. Kahelia? A question? Nope.
Yeah,
Oh, okay, sorry.
Kahelia, can you
Apart from the
unmute?
domain of the conference, what are the most distinguished? Well, well, there used to be this joke about what's the difference between FSE and ICSE, and the answer was 6 months. You know, MSR does a lot more mining of data, but MSR is a very open community. Like I've seen qualitative reasoning papers that are important and are useful and should be published at MSR. The distinguishing feature of an MSR paper when reviewing MSR papers, there's probably someone who's done this before, or some variant of this before. So at least have a so make sure that the paper references the prior stuff and stands on the vast body of work done before. And I'd like to ask Olga if we have time for more questions.
I think there is, let's take one more question. I think that's within the chat from Said.
Reviewing problems when no other solution approaches are available to compare. So the question is, what if it's a completely new area and this paper comes out of the blue? They're kind of rare. I mean, there's lots of, I mean, they do exist, but if it's a new out of the blue, there are certainly lots of choice points, even in a new method. A new method has a bunch of choice points, ranging from the most naive possible to the most, complexity. So I would ask that people, compare a new method against a much stupider one, because one of my salutary experiences is that many of my new grade ideas aren't better than some simpler one. And as a result of that comparison, I'm not recommending a simpler thing. I'd also ask, what does this paper give people into the future? Does it set up a baseline other people can explore? Does this paper offer a framework that lets dozens of other researchers jump in and contribute to this field? And is the second question separate? Reviewing empirical analysis papers? Syed? I don't understand the question, sorry. And Olga might cut us off here, by the way.
I think it's more on a general advice for reviewing empirical analysis. And I think one of the things you mentioned that, replication package would be nice to have.
Okay. I think, Syed, that's a bit broad because there's all manner of empirical analysis. So we might have to take that one offline or do that by email, but it's certainly a good question.
I think we are sort of a bit even late, but it was really insightful talk and discussion, team. So thank you so much for talking to us and sharing your experience today, and everybody else for joining us today and asking questions. Just as a reminder, Professor Grandi's talk will be on Monday, so if you want to attend that one, feel free to do so. One more question for team. I know the recording will be available, but would you be able to share the slides?
They're in the chat box right now. Tiny.cc 22 review. Tiny.cc 22 review. I think some of our Chinese colleagues have problems accessing tiny.cc. If that's the case, email me and I'll send you a copy.
Perfect. Thank you again, everybody. And this is the end of the session. And we will welcome your feedback on the session as well.